In this video, we'll discuss installing the FPV components on our racing drone. As a reminder, this video accompanies our text guide on propwash.com that you can use to follow the process step by step with pictures. Now that we have our quadcopter cleaned up and ready for line of sight flight, it's time to add some video gear so we can fly FPV. In general, FPV equipment includes two main components, the FPV camera and the video transmitter. The camera captures your flying footage, and the video transmitter, or VTX for short, broadcasts that footage so it can be picked up by our FPV goggles. In addition to the FPV camera and video transmitter, we'll need a few other parts to put everything together. Mainly, wiring that's included with your camera and VTX, a frequency chart so we can tune our VTX to see footage through our goggles, and an antenna to broadcast our footage more effectively. In addition, you likely received an OSD controller for the camera which you can use to customize the video settings. Next, let's talk about connecting our VTX and camera to a power source. There are a few ways you can approach powering your video system. Our method of choice is to hook the camera and VTX to the PDB, but this is going to require a PDB with a 12-volt regulator. If your PDB is missing this, you're going to need to either purchase one separately or hook your VTX and camera directly to your battery power. If you do hook your video system to a 12-volt regulator, be aware that you're going to have to use a 4S or greater battery or use a step-up, step-down regulator, which is not included in most PDBs. We recommend all pilots start with 4S batteries anyways, but it's worth being aware of. On the other hand, if you hook your video system directly to the battery, carefully read through your manual for both the VTX and camera to ensure that they support the voltages that you're going to be using. You should also be aware that using battery power leaves you vulnerable to video noise problems. Okay, so after you've decided how you're going to power your setup, let's tin our PDB. First up, we need to tell our PDB what voltage to send to the video system. This is done by joining two copper pads together with solder in a process that's called bridging. We need to bridge the two 12-volt pads to power our components. To do this, we want to tin one of the pads and use a sweeping motion with our soldering iron to move the solder to the other pad. You want enough solder to cover both pads, but take it slow. These pads tend to be tightly grouped, so you don't want to accidentally get solder on any other pads. Now that everything's tinned and ready to go, let's make sure we have our wiring in order. Again, this is going to be another read the manual exercise. For the most part, you want to identify the connectors on your VTX as well as the corresponding cabling for the voltage input. We'll connect the power, ground, and video input wires to the PDB. If your cabling has additional voltage output wires, we'll snip those away to clean everything up. We can remove the extra wires from the connectors just like we did with the servo cables on the flight controller. The camera should be much easier. Most camera setups will have one or two connections on the back plate. We want to look for the connection that supplies power and gets a video signal. Find the cable that fits in that connection and plug it in. Now that we have our cables and PDB prepped, it's time to measure and cut our wiring and solder everything to the board. First, plug the wiring you've selected into your camera and VTX. When measuring the camera wire length to the PDB, we like to leave a little bit of extra length compared to our other connections. It's because down the line when we need to make repairs, being able to access and remove the camera easily will be extremely helpful. On the other hand, our VTX can be mounted a little tighter compared to the camera since we likely won't be replacing it anytime soon. In terms of choosing a mount point, we like using the underside of the top plate as the VTX connectors are easy to unplug if we ever need to remove the top plate and do any repairs later on. After everything is sized and trimmed, let's solder the connectors onto the board. Like we've done before, we're just going to expose a little bit of wire using our fingertips so we can connect the minimum amount of wire needed. These pads tend to be super small, and we don't want to accidentally bridge any of the connections with a bunch of extra exposed wire. If you accidentally pull off too much of the covering, you can always use your wire cutters to clip away the excess. Once you have all the wires prepared, tin and solder them onto the correct pads. Solder these cables facing inward to help prevent any accidental prop cuts. After you finish soldering, it's time to test everything out. Before we plug in our battery, we need to do two things. First, whenever we apply power to our VTX, we always want to have an antenna attached. You can easily fry your VTX if you fail to attach an antenna. Even the cheap linear antenna that came with your VTX will work if you don't have another option at this point. If you're looking for antennas, we covered them in detail over on propwash.com if you need any recommendations. Additionally, as we discussed previously, we highly recommend the use of a Smokestopper to protect your gear on initial power-up. A Smokestopper basically puts a fuse in between your battery and all of your brand new quadcopter equipment. Instead of blowing up your new gear, it's going to trip the fuse in case of a fault and save you a lot of money in the process. We have a whole article dedicated to Smokestoppers on propwash.com that you can check out for more details. So after we attached our antenna, Smokestopper, and battery, let's double check to make sure that the voltage for our camera and VTX are working correctly. Probe the PDB on the 12 volt pads and check that the voltage reads somewhere around 12 volts. Be careful not to short the probes together. Now that we know everything is working, let's test out the camera. If your camera came with one, plug in the OSD controller that allows you to change the camera settings. Next, use the frequency manual to set a channel on your VTX that you can see on your goggles. Once you match your goggles with the VTX frequency, you should see through the camera. The image may be blurry, and if it is, the focus can be adjusted by loosening the tension ring on the camera lens and screwing the lens in and out. Next, we want to configure the settings on the camera. Using the OSD controller, or whatever device was included, go ahead and configure any settings that you would like to change. A lot of these settings will be personal preference, but we like upping the color gain as it'll make branches and other hard to see objects more apparent when flying. We have an article on this at PropWash that can help get your camera set up perfect. Finally, we'll mount the components. The VTX is easy. Grab some double-sided tape, cut it to size, and attach one side of the frame and the VTX to the other. We already have a mount slot for our antenna on our frame. To utilize a mount like this, unscrew the nuts from the SMA connector, slide the connector through the hole in the frame, and screw the nut and lock nuts back into place from the top of the frame. If your frame doesn't have an antenna mount, you can either make one of your own or mount your VTX further back and slightly bend your antenna around the frame. If you ever need to take the top plate off, simply detach the VTX cable and you're good to go. Just make sure you reattach it when reconnecting the top plate. Next, we'll mount the camera. Our frame came with two side plates for holding the camera in place, as well as a flat front plate to hold the lens. We're going to get rid of that front plate mainly because it holds the camera at too low of an angle. You want to have your camera tilted back so that you're looking at the horizon rather than the ground when flying. The faster you fly, the more tilt that will be required. Take your camera, make sure the orientation is correct, and fit it into the side slots in the plates. The mounting hole you use will depend on how much room you have left on the frame, as well as what camera tilt you'd like. Play around with the angling to see what works best for you. We recommend 0 to 10 degree tilt for beginners, but you'll likely move to 20 to 30 degree tilt in the near future with some practice. Try to mount your camera in a way that puts the lens behind the front of the frame. If you accidentally crash head first, you don't want to shatter the lens. You want the frame to take the beating instead. Play around with your camera mount to find an angle that works for your flying ability and protects the lens of your camera. Once you've figured out what angle you want to use, you can secure the screw through the plate into the mounting points on the camera. Don't over tighten here. Just tighten each screw enough so that the camera holds at the angle that you want. Do a final check on your goggles to see if everything looks okay before sealing everything up. Once you've confirmed everything's working, go ahead and connect your top plate to the frame. Congratulations! With the FPV system installed, you've successfully built your first quadcopter. If you haven't already, our next step is going to be customizing our flight controller software to make sure that everything's running safely before we get airborne. Check out our software setup video for a full walkthrough. Thanks for watching our Build a Drone series. If you're looking for more guides, reviews, and other resources, you can subscribe here and be sure to visit us over at propwash.com.